Okay, well, there's enough for me to go on another lecture. It's not going to be the whole, maybe not. So what do we do first? Isolate the inequality by itself, absolute value, otherwise it's not going to work. And how do you do that? You divide, okay, you know what? You divide by -3 both sides. What happened whenever I divide by a negative? I switch that symbol. So it's very important to isolate the inequality by itself before you decide whether it's less than or greater than. Greater than 2 minus x is greater than 5, or 2 minus x is less than -5, if you remember. Now I need to solve. Subtract 2 from both sides. Divide by a negative. Don't you switch the sign? From both sides. Divide by a negative. So now the numbers changed slightly, and they changed in the form. They don't match anymore. That's okay because it's shifted. And what that means, take -3 less than, take 7 greater than, and if you read this left to right, this reads, from the left it's going to hit all the way to -infinity, -3, again always left to right, no exceptions. And that takes care of that problem. Next problem, again before you say I want to get rid of the fractions, isolate the absolute value by itself first. Divide by 2 both sides. There it is. Now you see a less than, whatever's inside the absolute value, double inequalities. Now that you don't have an absolute value anymore, you think of an LCD and all of that other nice stuff. LCD is 3. If you do this enough, like I'm going to make you do it, you'll start working this out in your head and jumping to the next step right away. Add 1 to each side. Done deal. Sketch the graphical solution. -5 and 7 included. X is between those. The interval notation solution. From left to right, -5 is the first point we encounter all the way to 7. And the same deal here, we isolate the absolute value by itself first. Subtract 5 from both sides. Divide by a -1, and what happens when you divide by a negative? You switch the sign. Now that you have an absolute value on one side, everything else on the other side, this is an exception. And why is that? Because an absolute value is always greater than a negative. So at this stage right here, you put stop and say, if you don't see it, not a big deal. You could work this out. You write it one time as you see it. Or x plus 4 is less than or equal to 2. You solve, subtract 4 from both sides. Subtract 4 from both sides. And if you put this on a number line, this reads x is bigger than -6 or equal. X is less than or equal to -2, but -2 is to the right. And do you notice that we shaded the whole number line? And you would say -infinity to infinity. So if you recognize that, an absolute value greater than a negative, that's all the time. An absolute value is less than a negative, that's no solution. That could never happen. A positive can never be less than a negative. That's just a note. If you see it, that's why we isolate the absolute value by itself first. That saves us a lot of work. Now we get to nonlinear, something you might not be familiar with. Non-linear inequalities. Students want to treat non-linear inequalities like linear inequalities. They can't. That's not optional. So, what do you have to do? Well, you have two choices. Either you graph or you make a number line chart. To make a number line chart, you need to get those multiplied. Where does this equal 0? At 0. Not included. Where does this equal 0? At 3. Not included. So I have 3 regions to study. I need to focus on 3 regions. First region will be right there. So what I'll do, I'll pick a point in there, say -1. When I say this is less than 0, doesn't that mean positive? Well, -1 in there, x equal -1. Wouldn't that be a negative? -1 minus 3, isn't that a negative? You don't care whether it's positive or negative. You don't care about the number, you just care whether it's positive or negative. If you multiply two negatives, isn't that a positive? You pick a point between 0 and 3, let's say 2. If you put a 2 in there for x, that's positive 2, times 2 minus 3, isn't that a -1? Positive times a negative is a negative. And if you pick a point in there, say 5, put 5 for x, that's positive, and 5 minus 3 is positive. Two positives will yield a positive. You want to know, where is this less than 0? Isn't that from 0 to 3? So either you sketch a graph of this parabola, which we're not there yet, or you make a number line testing chart. Now, get to the next point. I know that you're tempted to divide by x. You can't do that. This is a polynomial. You get everything on one side, 0 on the other side. You factor. If you factor it completely, that's what it's going to be, x squared minus 1. Yeah. So here I have 3 numbers to test. Not to worry. I have to worry about 0, a -1, and a 1. 3 numbers, which means I have to worry about all of these 4 regions. Pick a point to the left of -1, say -2. -2 minus 1 is -3. -2 plus 1 is negative. 3 negatives multiplied will give a positive. How about a point between -1 and 0? Say -1/2. That's a negative. -1/2 minus 1 is a negative. And dang it, it's so hard to erase. -1/2 in there, that's negative. -1/2 minus 1 is negative. -1/2 plus 1 is positive. So if I have 2 negatives multiplied, that's a positive. A point between 0 and 1, let's say 1/2. So 1/2 in the first, that's positive. 1/2 minus 1 is negative, and 1/2 plus 1 is positive. 1 negative, those are multiplied, right? And how about to the right of 1, let's say 2. Positive. 2 minus 1 is positive, 2 plus 1 is positive. I want to know, where is this bigger than 0? Isn't bigger than 0 meaning positive? But it's included. So where are we talking about? Where is it positive? It's positive here, here, and here. So how do you write that? -infinity to -1 union with negative 1 to 0. You know what? You could include both of those. One shot. They're all included, right? So you could say negative infinity to 0 union with 1 to infinity. Again, wherever it is positive. And I look at the next problem. I notice that's a polynomial. I know solve polynomials. Get everything on one side, 0 on the other side. Factor. Two numbers to test. That's pretty good. Since they're multiplied. Negative 1 and 4. Those are included. A point to the left of negative 1, say negative 2. Negative 2 minus 4 is negative 6. Negative 2 plus 1 is negative. Two negatives will give a positive, multiplied or divided. Between a negative and a positive, 0 is ideal. 0 minus 4 is negative, and 0 plus 1 is positive. So that's positive. They alternate most of the time, but not always. Notice here they didn't alternate. And a point to the right of 4, say 5. 5 minus 4 is positive, and 5 plus 1 is positive. So we want to know, where is this less than or equal to 0? It's less or equal to 0 nowhere. Do you notice all of these are given positives? Something's not right. If I put a 0, oh, this was negative, right? This was negative times a positive is a negative. So where is it less than 0? It's less than 0 right here. So the solution is negative 1 to 4 included. Couple more to go. Another polynomial, I know to factor that. Factor out x squared. And if I take x minus 1 out, I'll have x squared minus 1. Factor that. That is x minus 1 into x plus 1. And wouldn't that make this x minus 1 squared times x plus 1? Now, why is that important? That's very important because when I get to the number line and I want to do my testing, that's a 1, that's a negative 1. Keep in mind, they're not included, that this is always positive, and this is 0 right there. So I only have to test this 1 point, that's it, because this is not going to contribute anything. A point to the left of negative 1, say negative 2. I don't worry about that because positive in multiplication doesn't change anything. Negative 2 plus 1 is negative. To the right, say 0. 0 plus 1 is positive. Automatically, that's the same. And if you're not sure, just test it in the other one. It doesn't matter. I want to know, where is this bigger than 0? Where is it positive? It's positive. From negative 1 to 0. Oops, from negative 1 to 1. Union with 1 to infinity. So, we're going to graph all of those later on. Until then, this is the only way to do the problem. X squared minus 25 is less than 0. X minus 5. And once we graph those, you have a much quicker way of doing this, and an easier option. But now, this is all you could do. This is a 5. This is a negative 5, not included. 3 points, 3 regions to test. Say negative 6. Negative 6 minus 5 is negative. Negative 6 plus 1 is negative. Two negatives multiplied will give a positive. A point between negative and a positive 0, put a 0 in there. That's a negative 5 times positive 5, that's a negative. And a point to the right, say 10. 10 minus 5 is positive, 10 plus 5 is positive. Two positives will leave the positive. Where is this less than 0? It is from negative 5 to 5, not included. Okay, 3 more examples to go. What if I have a rational? Again, we're going to graph this as well. Same deal. If you have a rational, you get a single fraction at the top and the bottom. Where does the top equal 0? At -3. Where does the bottom equal 0? At 2. Since multiplying and dividing have the same signs, sign-wise, now it's greater than or equal, which means that 3 I will include. But do we see why, even though it says greater than or equal, one more time, -3, again, we have less greater than or equal, oh boy. So, even though it's included, the -3 we include, because that could equal 0, but the 2 we exclude. And the reason for that, it's in the denominator. I can't have a 2 in the denominator. And I do the same thing. I pick 3 test points. A point to the left of -3, say -4. Well, -4 plus 3 is a negative. -4 minus 2 is a negative. 2 negatives divided will give you a positive. So the same way, a point between a negative and a positive, 0. 0 plus 3 is positive, and 0 minus 2 is negative. Positive divided by a negative is a negative. And say 3 plus 3 is positive, and 3 minus 2 is positive. I want to know, where is this bigger than 0, meaning where is it positive? And obviously it's positive from -infinity to -3 included, union with 2 to infinity. And the 2, even though it says greater than or equal, I can't include because it's not in the domain. When does domain apply? On every single problem you will ever do in math. And if I see a problem like this, nice looking problem, don't be deceived. You must get single terms to get the zeros. You can't cross multiply. I know you're tempted. The LCD is 2x plus 1. So multiply by 2x plus 1 top and bottom. That's a 0 by the way. That's x minus 7. And a negative 2x. Okay, take that back. I'm going to slow down and do it one more time. So first things you do, you get everything on one side 0 on the other side, because that's not a linear equation. You find the LCD, which is 2x plus 1, multiply top and bottom by that, and now you say I have a 2x plus 1 times x minus 7 minus 6x minus 3. And you would say I have a negative 5x minus 10 over 2x plus 1. I want to know, where's that less than 0? Well, guess what? Same deal. You would think, okay, where can I set the top equal to 0? The top equals 0 when x equals a negative 2. And the bottom equals 0 when x equals negative 1/2. Since that's not included, open circle on both. Now, I do my testing. I pick a point to the left of negative 2, say negative 3. Negative 3 times negative 5 is positive 15 minus 10 is positive. And negative 6 plus 1 is negative. Positive over a negative is a negative. A point between negative 1/2 and negative 2. Negative 1. That's a perfect point. Take negative 1 as a test point. Minus a negative 5 is positive 5 minus 10 is negative. And negative 2 plus 1 is negative. Two negatives multiplied or divided will give a positive. And a point to the right says 0. The top is a negative 10. And the bottom is a positive 1. That's a positive. Negative, I'm sorry. I want to know, where is this less than 0? Wherever it's negative. That is from negative infinity to negative 2. union with negative 1/2 to infinity. And last but not least will be that lovely problem. It's a bit longer than usual, but it's okay. We could handle that pain. So one thing not to do is to treat this like an equal. It's not. This is not linear. X appears in the denominator. Get everything on one side, 0 on the other side. LCD is x into x plus 1. This is missing an x. This is missing an x plus 1. But this is missing the whole thing. That's x into, so that's x squared plus x, right? So now that they all have the same denominator, I write it down because this is not an equal. X into x plus 1. The top will be 3x plus 2x plus 2 minus 2x squared minus 2x. What a problem. The denominator I'm just going to drag with me. As for the top, negative 2x squared. Those two cancel out. Plus 3x plus 2. Or I could say, take a negative out, right? That is 2x squared minus 3x minus 2. There's a price for that, but it's okay. Factor the top. That is 2x and an x, a minus 2 and a plus 1. Lovely. There, almost done. Okay, just went overboard. Oh my god. Okay. So how does that work? I will have to test a lot of points here. Negative 1/2. 2. 0. And a negative 1. I have to test 1, 2, 3, 4, 5. Negative 2. Remember there's a minus there. So that's a negative. Negative 4 plus 1 is negative. Negative 2 minus 2 is negative. Negative 2, that's a negative, and negative 2 plus 1 is a negative. 5 negatives will yield a negative. Those are what? The negative 1/2 is included. The 2 is included. The 0 I can't include because that's in the denominator, and the negative 1 I can't include because that's in the denominator. How about a point between negative 1 and negative 1/2? So say negative 0.75 or negative 3/4. Negative 2 times that is negative 1.5 plus 1 is negative. Negative 0.75 plus 2 is negative. There's a negative up front. That's 3 negatives. Right? So that's a negative, and a negative. Over. Negative 0.75. Negative 0.75 plus 1 is positive. 4 negatives will yield a positive. A point between negative 1/2 and 0. How about negative 1/4, which is negative 0.25? There's a minus there. A fourth of 1 is a half plus 1, so negative 1/2 plus 1 is positive. Negative 1/4 minus 2 is negative. Negative 1/4 is negative, and negative 1/4 plus 1 is positive. So we have 3 negatives, that's a negative. Between 0 and 2, 1, let's go for 1. Negative right there. Negative 2 plus 1 is negative. Negative 2 minus 1 is negative. A negative there, and a negative 2 plus 1 is negative. So they're all, oh, I'm sorry, 1, we said 1. Take that back. I messed up. There's the 2. We said let's pick 1. I should have picked 0. Oh, you can't pick 0. Okay, why am I making... Oh. There. So we picked 1. A negative. 2 plus 1 is positive. 1 minus 2 is negative. A positive 1 and 1 plus 1 is positive. So 2 negatives will leave a positive and a point to the right of 2. I have a minus already right there. Say 3. 6 plus 1 is positive. And 3 minus 1 is positive. Positive and a positive. So that's a negative. A lot of work. Where is this bigger than 0? It's bigger than 0 from negative 1 to negative 1/2 union with (0 to 2). And that concludes this section.